All right, welcome to this explainer. Today we're unpacking a staggeringly massive new FCC filing from SpaceX that could quite literally rewrite the entire architecture of global connectivity. If you've been following AI news and infrastructure lately, you know that data transport is basically the biggest bottleneck we're facing right now. While SpaceX is proposing a solution so huge it almost sounds like science fiction. But it is very real, and the blueprints are officially on the table. So here's our roadmap for today. We're going to cover the 100,000 satellite proposal, upgrading to gigabit speeds, Starship as the heavy lifter, powering the AI future, and finally, constellation challenges and competitors. Let's get right into it. Section 1, the 100,000 satellite proposal, scaling the orbital infrastructure. 100,000. I mean, just let that number sink in for a second. That is the jaw-dropping number of third-generation, or Gen3, satellites SpaceX wants to launch into very low Earth orbit. This isn't just some, incremental little upgrade to their existing network. We are talking about a proposal to build an orbital infrastructure so incredibly dense, it completely changes the math on how global data routing actually works. To put that into perspective, independent tracking recently put the current Starlink constellation at just over 10,400 active satellites. SpaceX essentially wants to multiply that active hardware by nearly 10. So we're going from what's currently a web of satellites to basically a dense mesh blanket wrapping the entire planet. Okay, moving to Section 2. Upgrading to gigabit speeds, redefining capacity and latency. The physical changes to these satellites are just wild. The current Gen 2 mini satellites weigh about 800 kilograms. But the proposed Gen 3 satellites, they are absolute behemoths. We're talking 2,000 to 2,500 kilograms. That's over 2 tons for a single satellite. And they are designed to fly much, much closer to Earth, dropping from their current 550-kilometer altitude down to the 323 to 477.5-kilometer range. This drop in altitude means they're going to be operating in what's called VLEO, or very low Earth orbit. Now, this is the absolute game changer here. By bringing the hardware physically closer to the ground antennas, the signal simply has less distance to travel. That physical proximity is exactly how SpaceX is aiming for those ultra-low latency multi-gigabit symmetrical broadband speeds that actually rival terrestrial fiber optics. We're talking about dropping the current 30 to 50 millisecond latency floor down to a lightning-fast sub-20 milliseconds. If you're a gamer, a day trader, or an engineer running remote automated AI systems, you know for a fact that those shaved milliseconds change the entire feel and performance of a network. But here's the catch. To squeeze out the astonishing 100 times total bandwidth increase that SpaceX is claiming, they have to move way beyond standard spectrum bands. So they're pioneering the use of W and D band frequencies, sitting way up there between 92 and 275 gigahertz. This is basically untapped real estate in the spectrum, which allows for incredibly wide channels. It's absolutely perfect for high-capacity backhaul and just massive uplink data. Section 3. Starship, the heavy lifter, delivering 2-ton satellites to orbit. So, the obvious multi-billion-dollar question is, how do you actually get 100,000 2-ton satellites into space? Well, you absolutely can't do it with current rockets. The reliable workhorse, the Falcon 9, simply can't handle that kind of bulk. Right now, it carries about 27 of the smaller Gen 2 minis. To lift these new 2-ton Gen 3s, SpaceX is entirely dependent on Starship, which can carry about 60 of these heavy satellites per flight. Starship is literally the only viable launch vehicle for a constellation of this magnitude. Do the math on that, and it means deploying the full Gen 3 constellation requires an absolutely mind-boggling launch cadence. If Starship carries 60 satellites at a time, getting 100,000 up there requires over 1,600 Starship flights. Think about the manufacturing, the fuel, the sheer logistics of that. It's an industrial undertaking on a scale we've literally never seen before in aerospace. Standing over 124 meters tall, which, by the way, is taller than the Apollo-era Saturn V, Starship is a fully reusable system with a 100-plus ton payload capacity. It represents the necessary logistical bridge between ambitious FCC paperwork and actual functioning hardware up in orbit. Simply put, without Starship flying regularly and reliably, Gen 3 is just a pipe dream. Section 4. Powering the AI future, connecting billions of devices. In their FCC filing, SpaceX explicitly noted this network is designed for billions of AI-powered devices worldwide, For developers, this is the ultimate infrastructure solution. AI workloads require massive uplink capacity to move high-definition spatial and auditory data in real time. We're talking about routing heavy edge computing workloads and remote AI training pipelines, whether that's for autonomous tractors out in rural agriculture, maritime drones, or even defense systems, directly through a predictable, high-throughput satellite mesh network. But, developers are actually going to have to adapt to this new reality. These satellites are going to feature massive 300 to 400 square meters solar arrays just to power advanced intersatellite laser links. That means the actual data routing is happening in space. Developers will need to update their applications to handle these dynamic new routing systems. Plus, those ultra-high W and D band frequencies, they're really susceptible to weather, like atmospheric attenuation. So software will need to use adaptive modulation and coding, which is basically adjusting the signal on the fly just to keep data flowing smoothly when it's pouring rain over a ground station.
Section 5. Constellation Challenges and Competitors. Navigating the Ecosystem.
Now, a leap this massive doesn't happen in a vacuum. Competitors are definitely trying to get off the ground. Amazon's LEO Internet is preparing for its initial service. Eutelsat OneWeb is focusing heavily on enterprise business rather than everyday consumers. Meanwhile, legacy geostationary providers like HughesNet and Viasat are seriously struggling to keep up with these massive low Earth orbit speeds. HughesNet even recently struck a deal to refer some of its own customers to Starlink. So Starlink remains the dominant force for sure, but you can bet these rivals are watching the FCC's every single move, completely ready to challenge those spectrum allocations.
And, of course, as an impartial explainer of the facts, we absolutely have to note the severe pushback coming from the scientific community. A recent study by the European Southern Observatory explicitly argued that massive constellations like this could have devastating effects on astronomy. The FCC has a really tough balancing act here. They have to weigh the incredible benefits of a global gigabit AI infrastructure against some incredibly valid concerns over space debris, light pollution blocking out the cosmos, and spectrum interference. So the reality is that SpaceX is laying the groundwork for a network that functions a lot less like traditional satellites and a lot more like floating orbital data centers. And I'll leave you with this provocative thought to ponder. If the FCC actually approves this, how will a sky filled with 100,000 orbiting data nodes forever change the future of the internet, artificial intelligence, and what it fundamentally means to be connected on Earth? Thank you so much for joining me for this explainer, and definitely keep your eyes on the sky and on those FCC dockets.